So on here, what we're going to do is just review on the front, and on the back you get one more step, but most of it is review. Read the directions carefully. Realize there are a lot of things to do here. So like here it says find the vertex. That's the first thing. Now the axis of symmetry, that's just the x coordinate of the vertex, right? And the min to max, that is just the y coordinate of the vertex. Okay. And how do you know if it's a min or a max? It's one or the other. It's not both. You're not finding the min and finding the max. It's one or the other. So that depends on the direction of opening. Right. So right here, it's a min, the vertex, right, if it's opening upward, because the vertex is going to be at the lowest point of the graph. And then it'll be a max if it's opening downward. Because like if an object's going up in the air and coming back down, the vertex would be the highest point that object gets in the air. So it's one or the other. So you kind of have to answer this one right here in order to know if it's a min or a max. You already know the number no matter what. That's the vertex. But whether that number is a min or a max depends on if it's opening up or down. Right. Then you have the y-intercept, which is always 0, comma, and then whatever the y-intercept is. Okay. And then on the back, what we're going to do is throw in a fourth thing to find. That would be the x-intercepts. So you guys know how to find the x-intercepts when it's in this format. The question for today is, well, what if it's already in vertex form? You can't put this in the box. You can't put this in the x. And what if you didn't have a graph? How could you find those x-intercepts anyway? So, but everything else is going to be the same. So if you look at the directions, find the vertex, axis of symmetry, min or max. So those are all related, the reds. The direction on opening, okay, which is directly related to whether it's a min or a max. Find the y-intercept. That's when x equals 0, right? And then new would be find the x-intercept. So I'm only going to show you one new thing, and that's this fourth component. But other than that, everything on the back is the same as the front. So let's take a look. So as many of you already went through, you saw this is in standard form, so we have to factor it. Right? We said what two numbers add to -20? It's -10 and -10, which multiply to 100. So this is the C. This is completing the square. That's the number that completes the square. Makes it a perfect square. Right? Plus 100. And then since this actually equals 104, we have to add 4 more. And via this factoring right here, we already know that this factors to x minus 10, x minus 10, right? Which is the same as x minus 10 to the second power. And then you can bring down the 4. So your vertex is now at 10, comma 4. Right? And this is the axis of symmetry. Right? That's right here. X equals 10. That's the middle of your graph. And this is your, is this a min or a max? Yeah, it's a min. Right? Because this is positive, so we know it opens up. So wherever the vertex is, it's going to be at the bottom, the lowest point of your graph. So I knew this was a min because it's a positive 1x squared. Right? What's the y-intercept? Yeah, if it was negative x squared, this would have been the maximum. So all those problems where you had some object going in the air and coming back down, those were all maximums because it was always a negative x squared is facing down. And the y-intercept, right? Two ways of doing it. You can plug in 0 into here, right? Which is 100 plus 4, which is 104. But then you realize, oh, that's the same as the C value. You already kind of knew that from the very beginning. So the y-intercept is 0, 104. Now, did we answer every question? What's missing? Direction of opening is up. Opening up because it's a positive a, positive x squared term. Okay. Good. So you want to be able to do something like this in under a minute and not stop and say, wait a minute, how come? What do you do here? Do I factor it? Not have any of these pauses of what should I do? And a lot of that is because there's so many different things you got to do on these problems. It's sometimes difficult to narrow it down. Okay, where do I start? So reading the directions and identifying, okay, with these directions, the question's in standard form. So, and I need to find the vertex. So I need to complete the square, and knowing when I say complete the square, you know that involves finding the C value. So a lot of this is going to be different from some of the other math you've done where you just kind of do the same thing over and over and over. On here, it really depends. Are you given the standard form or the vertex form? Because if you have to find the vertex, like on the back, right, it says find the vertex. Well, guess what? It's already in vertex form, right? It's already given to you. It's 2, -4. We didn't have to complete the square. We didn't have to find the C value. We didn't have to do all that stuff. So what a big difference. But unless you know the differences between the type of questions you can be asked and the directions, it won't matter if you know how to do them if you don't know when to do them. So be very mindful of, okay, if I have a vertex form, that's easier because I already have the vertex. Here, I said find the vertex, and look at all this work I had to do just to get it on your own. Okay. Now, when you don't have the vertex form, the y-intercept is a little bit of work. You have to plug it in. So when you go back on here and you do the y-intercept, you do have to do a little work, plug in 0, and find out what y equals, because you don't have the standard form. You can't just look at the last number like we did here and say, oh, it's 104. You know, real fast. You might have to calculate it. So that's why it might be confusing if you're like, I thought the y-intercept was the last number. Why do we have to plug it in? It's because there's 2 different types of questions. One that's standard form and one that's already vertex form. And it depends on what form you start with on what you do to get the answer. Okay? So that might help if you're kind of confused and changing your mind on how to do these. Number 3 through 6 is just a review. If it says to solve, what does that mean? What are you finding? What does this answer mean when you're asked to solve by factoring? Okay. Another way of asking this question would be find the x-intercepts. So knowing that once you solve this equation, if you graphed it, that'd be where it crosses the x-axis. So you have to get used to, oh, solve the equation by factoring. That's the same as finding x-intercepts. And that you can come across a question, and if I say on the quiz or test, find the x-intercepts, you're like, I have no idea how to do that. Well, that might be because all the directions that you've done up to this point said solve the equation. But they mean exactly the same thing. Okay? And it said x-intercepts. Sometimes it also says find the roots. Sometimes it says find the zeros, right? Because it's where it equals 0, right? Where y equals 0. And sometimes it could just be find the answer this. And they all mean the same thing. So once you clarify these directions and the idea that the question could be in 2 different formats, it might make it a little bit easier. So factoring. So this is what you did on April 12th on your test. Took a test on that. So what multiplies to -15m squared and adds to 14m? 15m and -m, right? So, and there were 2 ways of doing that. You can say do the factor by grouping, right? Replace 14 with 15 minus 1, same as 14, right? And then you said, what's the GCF for the first two, and what's the GCF for the second two, right? And whatever was in the parentheses, they had to be the same, right? So GCF here was 3m, left with m plus 5, which meant this had to be m plus 5. So these always, 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 right here, have to be the same. Right? And that makes the GCF here, what times m gives you negative m, and the same number times 5 gives you negative 5, and negative 1. So the first factor is 3m minus 1, and the second factor is m plus 5. Now the other option is doing the box. So if you prefer this, so I overheard someone saying, well, I don't know when to do the box and when to do the grouping. It's the same thing. They're just two different ways of doing the same thing. And like everything else, the more you do this, the more you practice, the more it makes sense. So if you are getting help on every problem or looking at your notes on every problem and it's still confusing, that's the issue. You have not done anything by yourself yet. As soon as you do it by yourself, it gets easier. If you just continue to get help on everything, it will never get easier because you're not learning how to do it by yourself. So even if you get help on something, my advice is, like I do on the reviews, take another one, take a blank homework. See if after you get help, you can now do it begin to end without any help and get it right. If so, that means you've done it by yourself. If not, that means you still don't know it. Don't just fill out the homework and say, look, I did it. You getting answers from everybody else is not you doing your homework. You know that. That's why it's not as easy for you. So just keep in mind what it actually takes to learn. So regardless, you see, you get the same two factors. So one or the other, you don't have to do both. Then you set them equal to 0. And the whole reason we're equal to 0 is because right here on the x-axis, this is the line y equals 0. So that's why they're equal to 0. So we have, what, 3m equals 1 if you add m to both sides. Add 1 to both sides, divide both sides by 3. So your first root is 1/3. Subtract 5 on both sides. Your second root, your second 0, your second x-intercept, your second answer. Those all mean the same thing. Root, intercept, 0. So your two intercepts are 1/3 and negative 5. It says solve, so it has to end with x equals. So you're already done when you have x equals. And keep in mind that these answers are the x's. What's the y coordinate of these? For both of those, if you're going to graph them. Yeah. It's assumed the y coordinates are 0 because we set it equal to 0. So when you actually graph these two, they mean 1/3, 0 and negative 5, 0. The y is equal to 0 because that's what we set it equal to. That's what these zeros stand for. As opposed to y equals 1, 2, 3, 4, or negative 1, negative 2, negative 3. Right? It's right in the middle, y equals 0. So your two answers are those x's. All right. On number 4, how do you factor this? It has a middle already. It's 24a. So this is where that test that you guys took really comes in handy. If you recall, let's bring this up. And bring up, and I see some people pulling it out. Where is it? Yeah. They're pulling this out because knowing this makes a big difference on how to solve all of these. So if you know this really well, you know what to do first, what to do second. If there's only two terms, what do you do? But if you're not following this, it's very difficult to like, well, I don't know how to start. So it's all based upon, like I said before spring break, this test makes a big difference on how much you know for the rest of the year. So there's two terms. So if you follow the right here, the first thing it says to do is check for GCF. So do that first. So what is the GCF here? Yeah, 3A. Can you factor this anymore? Well, actually, is this a difference of squares? That'd be if you follow the flow chart. Oh, two terms. It only has two terms. Is it a difference of squares? Is it like 4, 9, 36, 81? Any of those? No, 3 and 8. Those are not perfect squares. We can't do anything there. So from there, you can just solve. Right here, you're at the point we were right over here. See, we have two parentheses equal to 0. We're already at that point. We don't have to do all this other stuff because this only applies when there are 3 terms. So you only do all that when you have 3 terms. Then you use the X or the box and do all that. So that makes a big difference on how long this problem takes if you follow that flow chart. All right, so we get A equals 0. 3A plus 8 equals 0, which means 3A equals negative 8. Divide both sides by 3. So A equals negative 8 over 3. So we got 2 x-intercepts. One is 0, one at negative 8, comma 3. So that'd be the coordinate 0, comma 0, and negative 8 over 3, comma 0. All right. So the question is, if we try to graph this right now, and this is in vertex form, we know these come out to 0 and negative 8/3, which if this is 1 and this is 2 and this is 3, where would negative 8/3 be? That's negative, what's the ones digit on that decimal? Negative 2.6 or something like that, right? So the question is, if you had a parabola that looked like that, right? Not a very nice one. Could you tell that this answer, by looking at the graph only, is negative 8 over 3? No. And that's what brings us to today's assignment, is that while you guys didn't have to find the x-intercepts yesterday, if you did the t-chart or whatever, you'd find out they're like 1 and 3 or negative 2 and 5, something easy. But what if fractions are involved? We can't just look at the graph and say, oh yeah, that's definitely negative 8 over 3. Definitely not negative 10 over 3. Like, you can't look at that and just know what the fraction is. You have to have a algebraic way, non-graphing way of figuring that out. So when you get to the back, that's the only thing that's different from like number 1 and 2, is that we can figure these answers out without the actual graph. You do have to graph them, and if you want to graph it first, get the 2 answers, and then see if you get the same answers from the equation, that's fine. So let me show you how to get the x-intercepts from the equation only. And the rest of it, you already know how to do, is just review. All right, so let's start here. And just like the front, if I want to find x-intercepts, it's equal to 0. Right? So anytime you want to find x-intercepts or solve it, same idea. You want to know what is x equal to when y equals 0. So that has not changed. But we're going to solve this algebraically, meaning add this to both sides, divide both sides by this, and then you'll get x equals at the end. So here we go. The first step you probably already know. It's a -4. How do you undo a -4? Yeah, just go ahead and add it. So now we're left with x minus 2 squared equals 4. That equals 0. That's why there's nothing here. Now, here's something new. How do you get rid of to the second power? How do you undo it? We undid -4 by adding 4. How can you undo an exponent? Yep. Nope. We're going to do a direct. We could do that, but that'll take longer. But to get rid of a to the second power, you might remember back in the day, if you had something to the second power, and then you took it to the 1/2 power, that would effectively undo this, because when you multiply them together, you get to the 1 power, and they cancel out. Cancel out means equals 1. The 1/2 power, what's the same thing as a 1/2 power? Square root. So a 1/2 power was the same as a square root. So we can undo to the second power by taking the square root of both sides. So just like you've done before, you can undo negative by adding, undo division by multiplying. You can undo a power of 2 by taking a square root, right? And those effectively cancel each other out, and you're left with whatever is inside the radical. Okay. Now, what number squared equals 4? Right? So the square root of 4. So what number squared equals 4? And what else? What else? What other number? What other number times itself equals 4? -2. So you know how we have two answers on all these, right? Right? -1/3, -5, 0. We get two answers. So we have to be able to get two answers when we're doing it without a graph. And that's how you get those two answers. Because there are two numbers when you square it that equal 4. 2 squared equals 4, and -2 squared equals 4. So it's really 2 and -2. Get two answers. And then when you go through, you can add 2 to both sides. So we have x is equal to 4 and 0. We get our two x-intercepts. Okay. Now, other places, instead of writing it this way, they'd actually use this symbol, which you just read. You say that by saying plus or -2. So you can use this symbol as well, the plus or minus sign. This seems to work because for most people, but eventually this is what the standard will be. You'll do more of that on your homework. Kind of like with factoring, the standard is to do grouping. After a while, you just stop doing the box. So if this works at first, that's fine. If you want to start doing this right away, that's fine too. All right, so that's how you solve it. And again, those answers, it's if you do all that, but you don't know what 0 and 4 mean, that's kind of a problem. So remember, those are your x-intercepts right here. And your y-intercept would be, well, y-intercept would be 0 as well. So it turns out the x-intercept and the y-intercept happen to be the same here. But your vertex is 2, -4. And there you go. Please make your graphs a little nicer than mine. It's kind of hard drawing on this thing. So I'm going to do the left column now, just the solving, because if you look at them, they're all a little different from each other. The right-hand column is the equivalent of the left-hand column. It's going to go a little fast because we're limited on time, but you can always pull up the video again and watch it if you need to. So here we go. So this one is different because it has a negative in the front right here. See that? That wasn't in the first one. So the only thing different here is there's a negative 1. So there's going to be one extra step. So of course, we want to get x-intercept, so it's equal to 0. So like before, I'm going to subtract 4 on both sides. Now above, the second thing I did was to take the square root of both sides. But instead, because of this negative being right here, I'm going to divide both sides by -1. So it's a new step 2. If there's a number in the front here, you need to divide by that first before you do the square root. So now we have this equal to +4, and basically it looks like what it did above. Square root both sides. So we have x minus 1 is equal to 2. Is that correct? What's missing? -2 also, just like above. 2 answers that squared equal 4. 2 times 2 and -2 times -2. So now you can add 1 to both of those. So x equals 3 and -1. Now the alternative to this is just write x minus 1 equals plus or minus 2, and then you can add 1 to both sides. And just when you do this calculation, you just do both like the same thing you do here, and you get 3 and -1. So if you like this better, if you just want to use a plus or minus sign instead of doing this right here where I put a comma with 1 positive and then 1 negative, that's fine. It's okay to do that as well. We'll be using this symbol more in the end of the week for another method of solving. All right, good. And then you go back and you do all the other parts. So you still need to do axis symmetry, direction opening, min, max, everything else. All I did is the 4th part. Okay, you have to do the rest still. All right, on the next page, what's different about this? Yeah, there's no number out here. So if there's no number out here, that used to be the first step. We were adding 4, subtracting 4. But if there's no number there, you just go to the next step. So what would the next step be? Yeah, just like on the one above, there's a negative in front. So that now becomes the first step. So you see, they're all the same. They're just, well, this one you don't have to do the first step because there's no number there. Or like a number 2, oh, there's a negative there, so we have to do an extra step. But more often than not, it's basically the same format for everyone. All right, square root of both sides. Now, what is the square root of 0? 0 and what? Right, because up here we got square root of 4 is +2, -2, and so on. Is there a positive and negative 0? No. So again, a little tweak, but it just means there's only one answer. So the x-intercept, there's only one of them, and that's at -3. Wow. Yeah. Good. So yeah. So that means if you have one answer, yep, exactly. One x-intercept means it's also the vertex. Someone pointed out. So -3, 0 is also the vertex. And when you plug in, you find the y-intercept. It'll turn out to be, looks like -9. It'll be way down here, off the graph, really. It turns out that the x-intercept and the vertex are the same. When you have one answer, like we did here, meaning you get a 0 on the right-hand side. It doesn't happen very often because usually you get a negative or a positive. There's so many negatives and so many positives. Rarely does it come out to be exactly 0. But when you square root 0, there's only one answer, so you can't have you know, your two answers. All right. Lastly, we have negative x squared minus 1 equals 0, and let's solve that. And you can see here, there's nothing in parentheses. All these others had like x plus 3 in parentheses or x minus 1 parentheses. This doesn't have anything in parentheses. So kind of changes it a little bit, but not much. Same idea. Add 1 to both sides. We have negative x squared equals 1. And we have a negative 1 here. So just like we did above, we can divide by negative 1. And now we can take the square root of both sides. So what is the square root of both sides? What's the square root of negative 1? What times itself equals negative 1? Or put negative 1 in the calculator, take the square root of it. What do you get? Maybe a calculator, try that. Square root of negative 1 equals what? What do you get? It has to be the same number. What do you get? Oh, 1 times 1 is 1. What times itself equals negative 1? Nothing. There is no solution. You can't take the square root of a negative. No solution. Can you graph it? Of course you can graph it. It just means that there are no x-intercepts. So it looks like this. It does not cross the x-axis. That's why it comes out to a negative square root. There are no x-intercepts. Right? And we'll pick up on that on Thursday. Okay, tomorrow will just be review of yesterday and today combined together.